This is the content talk that will help you be introduced to why it is important and essential that in today's 21st century classrooms we consider the project approach as a vital curriculum and instructional tool to help expand children's communication, creativity, critical thinking, and their collaboration and cooperation in the learning environment. So why do projects? This is based on Young Investigators, the project approach in the early years. There are many reasons that we do project work. In this content talk, you will see many of those reasons as we discuss and learn about what teachers all over the world are doing when they conduct project work. To start an answer to this question, I'd like for you to look closely at the face of this child who is investigating the cockpit of an airplane as a part of the airplane project at UPC Discovery School in Peoria, Illinois. How would you describe how this child might be feeling? If you look at her closely, she's very comfortable, very self-assured. She has a slight look on her face that could allude to anticipation, excitement, joy, interest. Overall, she looks very satisfied. What she isn't is she's not bored, she's not unengaged, she's not unhappy, she's not fearful, and she's not unfocused. She's a confident, competent learner, someone who is exactly likely to be successful in her future schooling and her future world. To understand how that happens, we need to have a basic understanding of how children's intellect develops. You know, an old way of viewing intelligence is that intelligence was inborn. But what we now know is that intelligence and thinking and the brain itself is shaped by early experiences and experiences that build past the early childhood years. As experienced when you watched the Harvard Center for the Developing Child videos on the brain architecture, you were able to see how important and vital early experiences are to the education of young children. We do project work because the project approach helps children develop mind and brain capacity, or intellect. There are 4 basic processes which explain the creation of mind-brain capacity. Brain process 1. The basic cell of the brain is a neuron. This slide shows a diagram of a neuron. The yellow is a photo of a neuron taken with an electron microscope. A neuron is the basic cell of the brain. Typically, a neuron contains dendrites, the part that looks like tree branches, which are short fibers that receive messages from other neurons and relay those messages to the cell body, the large area with the nucleus, which directs all activities of the neuron. The axon is the long single fiber that then transmit messages from the cell body to the axon terminals, more short fibers which send messages to the dendrites. I like to think about this as from your shoulder, where the dendrites would be, throughout your arm as the axon, and then the axon terminals would be represented by your fingers. Every moment, messages are moving with amazing speed back and forth from neuron to neuron. As a matter of fact, scientists often compare this activity to how electricity works. The yellow is a photo of that neuron taken with an electron microscope. And so there we are really enlarging the optimal capacity that we could have to view what this looks like. The large reddish triangle is the body of the neuron. The other reddish spots are where the dendrites and axon terminals are connecting to other neurons via chemicals in the synaptic gap. This brain process also means that neurons communicate with other neurons in special networks. and these are places called synaptic gaps or synapses. To send a message, a neuron releases a chemical messenger or a neurotransmitter into that synaptic gap. From there, the neurotransmitter crosses the synapses and attaches to key sites. When neurotransmitters attach these receptors, they can change and cause changes inside the receiving neuron, and the message is delivered. This drawing shows the dendrites, which grow from the cell body. Impulses flow down the long axon. The axon sends in the axon terminals, which connects to the dendrites of another neuron. It's important to note that those axon terminals aren't necessarily touching that other neuron, but yet it's the synaptic gap that is creating the connection. There are approximately 86 billion neurons in the human brain. Each neuron may be connected up to 10,000 other neurons, passing signals to each other via many synaptic connections. Millions of synaptic connections. The components that look like hot dog buns attached to the axon terminal is illustrating that this axon is wrapped in myelin, which insulates the axon. It's that myelin sheath, which makes the electrical impulse stronger. Diseases such as multiple sclerosis and even stress can damage the myelin sheath. Brain process 2, chemicals released into gaps where neurons join shape these networks. Neurons don't actually touch their dendrites and terminals. They're connecting through chemicals. This is because there's a tiny gap. The sending neuron releases chemicals such as adrenaline, cortisol, serotonin, and others. You can look at those neurotransmitters in the interactive graphic that is posted to the Content Talk folder. This interactive graphic is from Harvard Center for the Developing Child, and it's very interesting to see how these neurotransmitters work to both aid and prohibit the development of the brain. If there are high levels of stress and chemicals, the messages slow up. New connections are ceased to be made, and retrieval is difficult. In other words, too much stress can make it difficult to learn. Adrenaline is that call to action. It can increase learning by alerting the brain to make more connections, to solve problems, to store information. When we talk about engaged learning, we're talking about children whose brains are awake, active, seeking, trying to reason, solve problems. Children who are bored are not able to study what they find interesting, and they tune out. They're not making connections. They're not building an efficient brain. Brain process 3 is that experiences shape the brain by reducing or creating connections. This is a classic illustration from Remus Shore, which shows what we currently think about the way neurons connect and shape the brain. At birth, most neurons are there, but they're still not connected. The brain goes through tremendous growth like a lilac bush in our backyard. It bursts with new branches and new leaves. Likewise, the newborn brain becomes this growing machine with rapid growth in dendrites and terminals and connections. Lilac bushes can become quite large and unmanageable, so the gardener prunes and shapes the bush, creating a lovely, more efficient garden. So then does the brain. However, the gardener for the brain is experiences that the child does or does not have, and brain development connections that are used will become stronger, and those that aren't used will disconnect or disappear. This is when I often say if you don't use it, you lose it. It's kind of like, can you remember 8th grade Algebra 1 and that quadratic formula, right? So a child can hear and make all the sounds that they babble. However, only those sounds that are heard in the environment will be kept. This is an example of how that language is pruned in the brain. Brain process 4. This is a diagram to make sure that you can consider how experiences are shaping the brain. There are areas in the brain that are used to shape the capacity. The sensory the sensory and post-sensory area is where information, stimulation is coming in. Concrete experiences stimulate these senses. So it's important to note concrete experiences. The younger child, the more concrete the experiences need to be in order for it to enter the child's consciousness. So concrete experiences don't mean interactions with symbols on paper, like written symbols or numerals. It means interacting with the objects, the real artifacts, props, and materials in their world. Then they put it into their consciousness, that stream of the mind. Information coming in is then integrated with previous experiences in the temporal integrative cortex, and it is reflected upon. An example of this is sitting on a park bench after it rains. At first you sit down noticing nothing, and gradually you get a message from your senses that your pants are feeling different. You reflect on your previous experience and observations with rain and realize the park bench is wet and the rain is what you just sat on. The front section of the brain is the frontal integrative cortex. This is where we think. Most executive function is located. Executive function are things like focus and attention, behavioral control, emotional control, the ability to have higher level thinking, such as abstract thinking, making a plan, solving a problem, making decisions, hypothesizing. So in our example of a rainy bench, the brain might be analyzing, what does this mean? The wetness is soaked in my pants. Now it's on my underwear. I wonder how much water is on this bench. I wonder what will happen if I get up. I wonder maybe if I stand up and get off this bench, it will be best. At the top of the brain is actually a band. It's like a headband from ear to ear, and that's our motor cortex. The premotor and motor actions originate here. So this is where the rainy bench story, you would think, all right, legs, get me off and do it now. So this motor is also where drawing, writing, painting, dancing, singing, talking, building, constructing, all of those actions would be directed. This is a very important area because we know that actually doing something about what we're thinking makes more connections and helps us remember and builds a foundation for more learning. We know that if we memorize something and say it out loud, we remember it better. If we write it down and illustrate it, we remember it even more. But if we create a presentation and actually present it to others, that's putting the information out and really building a robust brain. The conclusion of this idea is if you use it, you won't lose it. But otherwise, you've got to use it or you lose it. We do project work because the project approach helps children develop mind and brain capacity or intellect. The brain develops by making neural connections. Chemicals in the brain can support or inhibit learning, and project work brings about the positive chemicals that actually support brain development. Experiences shape the brain by reducing and creating more connections. Thinking creates the ability to think. All right, so now it's your turn to do a little thinking of your own. And as you have taken in information in your readings about the project approach, as you've put together some ideas about the expansion of the brain, mind, capacity through the work of project work, now we're going to think about how we explain this in our own elevator speech, because it's going to be important to share with administrators, colleagues, and families why it is we do what we do. So you're going to pretend that this Mr. Martian has come today from Planet Worksheet classroom and says, what on earth are you doing in your classroom here? What is it that you're so excited about? And as this Martian sees all of these teachers doing the project approach work, and you say, we're learning about projects. The question is, what is a project? So pause the video and just write out or draw an explanation for the project approach. It's important that you emphasize in your definition that the project approach is an approach to curriculum. It is not a full curriculum. It is separate. It's an alternative way to approach teaching, so instruction and interactions, as well as knowledge, skills, and dispositions that are part of the curriculum. That's actually a benefit because you can take any curriculum in terms of the standards. The curriculum is usually derived from learning standards, and you can weave them into this approach. There are many definitions for the word project. For example, sometimes decorating a room is a project, sewing a dress is a project, building a garage is a project, making a diorama of your favorite story is a project. But in the project approach means it is an approach to curriculum. A project must involve children developing the questions and finding the answers. We often start with the phrase, an in-depth study. So a teacher might say, we did a project last year. We went to the fire station and we built a fire truck. But if we ask the teacher what were the questions that the children asked and the teacher can't tell us, then the project was probably a thematic unit or teacher inquiry. It might have been an art project or a play experience. So if you think about that continuum of curriculum from single concept, integrated concept, unit, themes, teacher inquiry, and then project work, without the question, it's probably a thematic unit. To be a project, the project approach must have questions and investigation. It's an in-depth investigation of a topic that's worth studying about. The key feature of a project is that children's questions and their interests provide an integration opportunity for experiences in the real world connected to the learning standards and developmental aspects of their learning that children need to learn. We teach through inquiry because we want to benefit children's learning across domains, and we want to benefit how children can be connected to the curriculum content areas. So this is a good time to think about all of the different areas of learning domains, such as cognitive domain, language domain, social and emotional development, and physical. We also want to think about the content areas such as reading, writing, mathematics, science, technology, physical education, health and nutrition and safety, music, arts, etc. So let's take a quick review. When we think about that continua and the degree of child initiation and decision making, we have those single concept lessons. The teacher is determining the curriculum and the instruction for both of these. For the unit, the unified exploration of several concepts in different areas, usually a narrow topic, usually a curriculum company has determined this, and the teacher teaches it. Thematic teaching can be derived by the teacher or from students' initiation of a learning experience. It's usually over a broad topic. In a previous content talk, I used pumpkins as an example of that. Teacher-directed inquiry can be an in-depth exploration and investigation of a topic by the students, but it's under the teacher direction, meaning that the teacher is the primary person creating the problem, bringing the problem to the children's attention, and asking the questions, providing the questions for the children. Projects is when there's an in-depth investigation of a topic focused on finding answers to questions about the questions children have posed. Teachers do help support this, but they are learning alongside of the children, even when the teacher is knowledgeable on the topic. She or he is still guiding. We can emphasize one approach on one day and another on another, doing literally all of this continuum within our classrooms. All teaching can be good teaching. All of these things can be emphasized. All of these things can be emphasized. They're all good teaching, but we really must get over here. Besides developing mind-brain capacity, what else helps children develop through projects? Children have a reason to practice academic skills. Often they do that on their own. This is an example from a kindergarten classroom. This child was writing numerals and words that was recorded when they were observing llamas. In the middle of the frame there, you can see the child's phonetic spelling of llamas. You can see that they're recording that they eat grass, maybe no eggs. They're drinking the water that they've counted, lots of food, some that looked like dispositions. We also have to teach children dispositions for learning, being creative, taking initiative, having organization, making a plan. All children have these dispositions, but we can strengthen positive dispositions and weaken those less desirable ones through the work of projects. Children develop dispositions, being curious, being engaged, taking initiative, accepting responsibility, and having a positive attitude towards learning when they're in project work. Projects help develop self-esteem. They can address children's proficiencies about what they can do. This is an example from the movie theater project in Kathy Steinheimer's classroom at Velasca Hinton Early Childhood Center, which is at a university in Illinois. On the left-hand side, you see a documentation panel that was actually child initiated. It was created from artifacts, photos from their trip to the movie theater. The children in this particular group that made this display panel, made the display board on the left, they were really interested in how the movie theater worked. You can see pictures of the display board, what it looked like in the back room. You can see the wheels of the reels of movies. Of course, you know, that wouldn't happen now because all movies are digital, I think. I don't know. Maybe we should go to the movie theater and find out. But on the right-hand side, this was a child who was kind of on the peripheral of project work. And he came to do a lot of observing other children, but became increasingly interested in this master motherboard that controlled the movies. And so this was one of the first times that he initiated writing and doing things on his own. And you can see that he decided when he wanted to make this, and this would have been in phase 3, the culminating piece of the project work, he had to go over and find that display board, and then he put his work right on top of it so he could be sure to represent his board exactly like the real one that they had viewed at the movie theater. Project experiences are engaging and intriguing and interesting, and they really contribute to children's intellectual development. Sometimes stress can be damaging in learning, but a little bit of stress can actually create interest. That interest creates a chemical reaction in the brain, which enhances learning. So here you can see this young child's face on the right, a little bit unsure when the reptile expert brings some reptiles in, the turtles that came in for Linda Lundberg's turtle project. So, you know, sometimes we have to help children develop differences related to their feelings, fears, and so we can present information that could be a little fearful to children, and maybe even you all will read about the spider project later on in this course, and that usually always gets a little reaction from some of the students. Project work provides opportunities for children to determine what to work on, to take control of their learning, and to take initiative. Here is a boiler. A boiler is an old-fashioned way to heat buildings. Who would have imagined as a teacher? I'm sure none of us would have ever thought that a boiler would have been the topic of learning for pre-kindergarten children. This teacher couldn't do a field trip. She couldn't take her children out of the building for field site visits, which is an important critical part of project work. So she took them on an exploratory walk all around their old school and all around their program. And so the children were fascinated with this machine, the boiler. So one of the pieces of representation that came out of their long-term investigation of this boiler, they created their own. These pictures really help depict the similarities between the photo of the real boiler and the ones that the children created on their own. Democratic values can be fostered through project work. We also find that social justice issues and diversity issues can be brought to the forefront during project work. This is a toddler teacher, Katrina Larson, and her children were interacting with the street sweeper. There was a long-term investigation of different trucks by the older preschool classrooms, and the toddler children decided to focus in. So this street cleaner is answering questions about his machine. The toddler wanted to know about the bristles, and the gentleman actually pulled off some of the pieces for the toddler to feel and hold and explained it's like a toothbrush going through the street. So the children are able to value a variety of ways that individuals and occupations contribute to our world. Projects provide opportunities for children to try, to fail, to develop persistence in seeking solutions. This was from the Mexican Restaurant Project by Rebecca Wilson. So the children had been studying the Mexican restaurant owned by a family in their classroom, and at the end of the project, which was in phase 3, the children wanted to create their own Mexican restaurant, and they wanted to recreate a shelf that they saw in the actual restaurant. So they had found material to do this, but they were trying to figure out the best way to make the shelf strong so they would actually stay up when they put their materials on it. So they persisted in using lots of different types of adhesives and different links, testing and measuring and retesting. Lots of thinking going into it. So why do projects? Projects provide experiences which build mind-brain capacity. Projects engage children. Projects provide a reason to learn academic skills, and they build dispositions that are often not built into prescriptive, pre-planned learning curriculum and experiences.